Okay, I'll go ahead and get started. So welcome, everyone. As it says here, this is a test-driven approach to documenting RESTful APIs. And it's going to be with Groovy and Spring Red Sox, but most of the beginning is pretty generic. I'm Jen Strader, and my Twitter handle is CodeGenerator. I thought it was a pretty cute pun. Okay. So as an outline for today, I'm going to go over a little bit of background about API documentation in general, some different approaches that I've used and that you may have used, some things that we found as we were looking at different tooling, and then I'll dive into what is actually this concept of test-driven documentation, and specifically the implementation in Spring Red Sox. And as time allows, I'll go into some code examples and a demo. If you want to follow along, the slides are published after the presentation by the conference itself. There's a link that just went out on Twitter. It's automated. And then you'll be able to, from that presentation, download all of the example repositories and example code. So then a little bit about me too. So I am right now in Berlin. I started working for this cool new startup in June. It's called ZenJob, and like it says there, we have a software platform that fully automates your temporary staffing needs, and particularly with students. Before that, I spent a year in Copenhagen working on through a grant from the US State Department that let me work on some open source software and take some classes at a university. Even before that, I spent several years working as a developer. I was a consultant mostly in Minnesota. And the work that I did there is actually where this talk got started. Outside of my everyday, I also do a lot of work in the community. I co-founded an organization for women in tech, and I go and talk about that all around the world. So that is probably enough about me. I also want to hear a little bit about you. So I had kind of written this abstract with the idea that everyone, and hopefully by the time you've gotten to this point in the conference, you've at least seen how to create a RESTful API. But this is a very generic conference, so I understand if not everyone has this specific skill set. So does anyone use Spring Boot right now? Okay, so probably about a third or more. Is anyone actually using Grails? No. Okay. And I expect then that no one is familiar with Ratpack either. Okay, so we'll kind of stick to the Spring Boot examples then. Oh yeah, as the last one, are there any other MVC-like frameworks, Ruby, Rails, that kind of, there's regular Java? Okay, so I'll take a little bit more time to go through some of this. Now, that is how to create an API, and then there's different parts about how to document it. So these are just three that we were using, and three very different approaches to documentation, of course, that we were using in some of our projects. So who is familiar with using kind of just handwriting documentation, using wiki pages, maybe Confluence if you're... Okay, everyone has at least a working understanding of documentation in that way. Who has used something like Swagger or Raml? Okay. And who is familiar with AsciiDoc /AsciiDoc as a technology? Okay, so I'll just spend some more time on that. Okay. So now you know a little bit about me, I know a little bit about you. I feel pretty confident that I can share my secret. I hate writing documentation. Just like most developers, it is my least favorite task of a project. So, and the thing that makes it the least exciting part of my job is how tedious it can get sometimes. So I like to write code, that's my job, but it's not complete without having some documentation too. And so when I was tasked, gosh, it's been almost 2 years now, to create a centralized documentation solution for our big giant enterprise that I was consulting at the time, I was not really happy about the idea of writing everything out myself, or even asking my other developers on other teams to do that too. So we looked at some different tools that we could use to make it easier for us as developers to have good documentation for our APIs. And so the first step, of course, was to take a look at what things were important to us in the documentation tool, or the projects that we already had documentation for, as well as the projects that we wanted to add better documentation to. And so the first thing is where the APIs sit. And so this is a graphic that I pulled from an article from Martin Fowler, who, it's the Richardson REST model. Anyway, this is I like the categorization here. So you have this idea that if you have a level 0, it's basically just HTTP over, or CRUD over HTTP. Then maybe you start getting a little bit more organization, you have some resources, but you may not be following the full HTTP standard. And then all of these, of course, fall short of the ideal REST principles if you're following those. And when we looked at all of our different APIs, we found that most of them actually fell somewhere between this level 1 and level 2. So we weren't even using hypermedia yet, but we wanted to be open to it in the future, particularly with some of the new things that we were doing. And this became important when we were looking at different tools because some support hypermedia and some really don't. Okay. Then the next wonderful thing that happened is that we looked at how our architecture had evolved. So this, if you find this a little bit amusing, the idea here is that if you don't have a good solution when you break up your monolith into microservices, you still have those same problems in your microservice architecture. And now you have even more problems with distribution. When in the reference to documentation, this means that now instead of having one central place for our documentation to live, we have 5 or more different microservices that all need separate documentation. And we wanted a consistent place for we wanted a place for those to go, as well as we now need to show how these services work together. Okay. Another thing that came up was repetition. So there is some central information that you probably use across all of your different APIs and services. Things like your security protocol, the patterns for how you, like what HTTP verbs you use for certain actions, as well as maybe some status codes if you do something a little bit out of the ordinary. Yeah, okay. The last thing that kind of came up was design. It's just a small thing, maybe trivial to most, but for our product team, and particularly for our CTO at the time, this was a really big issue. The example on the left uses a library called Swagger UI. And for developers, this may make a lot of sense. It's endpoint based, you get your verbs, your post, your get. If you click on one of those links, it expands out into an example. But when our CTO looked at this, and particularly when our people in the PMO looked at it, they didn't understand what any of this meant because this was all tech jargon. So they really liked a different approach, which is one that Spring Red Sox and just general ASCII Doctor brings, and that is to group things by topic instead. So in our table of contents, we can use the words that they're familiar with, and then leave the technical bits to our individual examples. Okay. So once we decided kind of what was important concept-wise, we started looking at what tools cover some of these ideas. So the first thing is that we were sometimes using Swagger. So Swagger, of course, is not just about documentation. It's actually about the definitions. But there's a lot of overlap between some of the definitions and some of the documentation tools. So pure documentation tools like AsciiDoc, Markdown, or even just writing things out in some wikis. Okay. And then the next concept that came up is how do we ensure that these concepts are correct? So how do we integrate our API definitions with our documentation and testing? And so we had some other approaches there. But the kind of interesting one that I wanted to talk about today is this intersection between testing and documentation, which is where Spring Red Sox sits. But in order to get there, let's talk about all of the other pieces to this diagram. So first, there's Swagger. And Swagger is a lot of different things. At the core, though, the main part of Swagger is the standardization. So I think there was a talk on it yesterday. If you went to that one as well, you learned a lot more about what Swagger is and maybe some of the advantages, because there's a big plugin ecosystem around Swagger, including things like generating client libraries, generating documentation, and different ways to connect once you know that definition. And for our particular ecosystem, so on the JVM, there are two main approaches to adding Swagger to a project. The first one is, of course, through automation. And for us, that was a library called SpringFox. So SpringFox is really simple and easy to add, and it generates a Swagger specification based on your source code. It works really well for our simple cases. It was something that we were using in some of the existing services. Okay. So really, yeah, really easy to set up. You add a single dependency and some configuration. The other option is to specify your own. So if you aren't familiar with Swagger already, there's this definition for kind of what goes in it. And you can maintain this yourself instead of using an auto-generated tool. But I already talked about how I don't like writing documentation. I really don't want to have to make sure that this gets maintained too. So it really wasn't our first choice to go with keeping a Swagger file and just making sure we update it. The big problem here is that if you start making hotfixes, you start moving faster, then if you don't have any kind of synchronization for this documentation or this definition, it gets out of date as soon as you make the next field addition or change to your API. Okay. So once you have some sort of specification with Swagger, you can use tools like your build system, Gradle for example, to generate a UI. So this was, of course, the Swagger UI, but you don't necessarily have to use this particular one. There are lots of other libraries to take a Swagger specification and generate a UI. Okay. But there were, of course, some drawbacks to using this tool. And this was just mostly about our use cases. For lots of people, those are perfectly valid and good options. The first thing that came up is that we were doing a lot of overrides. So in the UI library in particular, we had to keep extending it out. The version of the SpringFox Swagger UI we were using didn't support custom headers. So we were using OAuth JWT tokens for our security, and we had to keep manipulating those files, or we had several APIs that just didn't have working try it buttons. We also kept having to redefine our data model and our data scheme, and because it didn't mean anything to our end users that we have this custom data object. We want to know what that means in real JSON. So particularly as the APIs got into this really custom embedded structure, using an auto-generated solution was not the best way to go. Now the next one, and actually I'm hoping now that this will soon be out of date, is that prior to the end of July, well, I should back up a little bit more. So when we did this analysis, we're currently on Swagger 2. Swagger has now moved to a complete renaming called Open API, and they released the 3.0 version at the end of July. In the 2.0 version, there was a lot of debate about whether or not to support hypermedia at all. And if you look at other presentations, you can see this very famous conversation in GitHub that went, "We will never support hypermedia." Luckily, in 3.0, they have changed that decision, and there's now a concept called links, which will hopefully be able to better support hypermedia. However, when I checked the other day, the SpringFox library, of course, hasn't been updated yet, so I can't look at and how that'll work together yet. Okay. But perhaps the most annoying thing that kept coming up is this concept of all of these annotations. So there's lots of annotations if most people were at least familiar with Spring or Spring Boot. There are lots of annotations in general. Now we're adding even more. So most of this is just related to the documentation. We weren't using Swagger for any of the other plugins or anything. So all we were doing was adding annotations to define our documentation. The real problem, though, is that there's no check on this. So we were we could write whatever we wanted in this section, and it doesn't even have to match the source code that's below it. If we remove that documentation, or those annotations related to the documentation, everything gets a lot shorter. So this example was actually one that I pulled from our source code in one of the projects that was using Swagger. If you think about just how much, and this is just on one method. So this is one example. Multiply that over every controller in a huge API, and there's a lot of time that you have to spend reading through these things. We can find a better way. But there is one advantage that Swagger brings that lots of people like, including our own teams. And that is this try it button. So when you take the any of those endpoints from Swagger UI and you click on it, it expands out into this view. And you can, in the white text, enter some kind of example data, and at the bottom, actually it's really tiny on here, click this try it button, and it will run that example against wherever you have this hosted. Usually this is really good for our QA environments. You can get that to work. But there was one thing that kind of came out of that, and that was a lazy approach to testing for our developers. So we were doing a lot of these manual tests. Oh, does it work with this one example case? But this may not always go through your security, all of your security setup. It's really just a small piece of the puzzle. We weren't writing as many automated tests and doing some of the other good practices as well. But there are some alternatives. So if you really like this try it feature of Swagger UI, you can, of course, use Postman too. So Postman is actually a product that we use at our company right now. We haven't hooked it into Spring Red Sox yet, but it's really nice for getting some examples. You can save those. If it's a public API, they have this button in the top where you can add to your documentation to say, run this in Postman, and it'll start up any examples that you include as a collection. You can also use old-fashioned curl. And it may be difficult to think, oh, what options do I need to add to get this to run? But with a solution like Spring Red Sox that can generate your curl statements for you, you don't even have to think about what's there. So to transition maybe from Swagger to Spring Red Sox, or if you like some features of one and some features of the other, you can kind of mix and match. And there are two libraries that will really help with that. The first one is called Swagger to Markup. So if you really like Swagger, but you don't like maybe that UI-centric UI, you can generate an ASCII Doc or a markdown or any other flavor front end. So this looks very similar to the Spring Red Sox UI. It's using the same tools and same libraries. And by default, you do get this path-centric approach again, but of course, this is a much more configurable tool. You can get that to work. The next thing that I mentioned is kind of that disconnect between what you wanted to happen and maybe what actually happened. So you can end up with my printing example that it doesn't quite match up. So you can use a library called assert.jswagger, which will ensure kind of a contract first approach. So it verifies that your Swagger specification that you generated actually matches what you had expected. So if you start making some changes, doing those hot fixes, this will help and make sure that those stay up to date. Okay. So that kind of fits in between where the definitions are and some basics of maybe testing and documentation. Okay, so now we can start talking about what is actually Spring Red Sox and this concept of test-driven documentation. And this kind of came out of the idea that there has to be something better, something that will cover some of these edge cases and reduce the friction that we were seeing. And the timing actually worked out really well for us because we were thinking kind of about this solution, and Spring Red Sox went 1.0 right around the same time. So what is test-driven documentation now? We take our classic red-green refactor cycle, and we start with our failing test, of course. But now we have to introduce documentation before our tests will go green. And this, when you start refactoring again, it means that your test will start failing because your documentation is now out of sync. And this really became kind of a breakaway winner because it does these things. It ensures that the documentation matches your implementation. We actually started writing more tests now. So in order to get good documentation, we need to write more tests. And we found a lot of bugs in the process, of course. And it reduces the duplication between just writing the docs out and things that we might have already been testing. It removed a lot of the annotations from the source code too. So our source code is easier to read, and we get some good tests. So the concept is not specific to any one framework, but there is one example that I know of, and that is Spring Red Sox. So Spring Red Sox goes even a little bit further than just adding test-driven documentation, and it really changed the whole way that our documentation worked. And that is because it generated the code snippets for us that were then easily injectable into code-generated documentation. It also helped us because the tests started to fail, and because it's all hooked into our build pipeline, the build fails when your tests fail, and the tests fail when your documentation fails. But two of the most interesting points is that it covers some of the cases that Swagger doesn't. So before Swagger had hypermedia, Spring Red Sox had an option for it. And it's actually pretty centric. If you read through the documentation for Spring Red Sox, most of the examples use hypermedia, and it's really been a focal point. It was also really helpful in another framework in the Groovy ecosystem called Ratpack. So Ratpack, as no one was unfortunately was familiar, is a really lightweight micro framework for the JVM, and it's really used in just creating these really small microservices, has some really good support for asynchronous processing, reactive stuff, all the new buzzwords. But the route handling is very unique, and it's dynamic. So you don't get a predefined list of URLs like you do with a lot of frameworks in a URL mappings table or something. It uses some pattern matching to determine how route handling is going to go. And when you have such a dynamic route handling, you can't use any kind of auto-generated solution. So the two options are to generate your own Swagger specification and manage that yourself, or to use Spring Red Sox. Okay. So now we've gone through all of the different steps, and hopefully you will start to look at Spring Red Sox. It's a documentation tool. The documentation's pretty good. So if you start at the website, it's an official Spring project, so it's listed there. We now have a logo and a Twitter account, and there's a lot of support for it. So it originally went 1.0 in the fall of 2015, so it's been around for about 2 years now. The current release version is 1.2, 1.2.1. We're in a little bit of a hiatus right now. There was a big push to get things to 1.2, and now the next road mark is, I think, going to be 2.0, but it's dependent on some things in the Spring ecosystem and updating all of that. It is, but also since it's a Spring project, it's not just about Java. I use it for our Groovy project, and you could even use it for Kotlin. So there are, of course, lots of different applications of this. If you are coming from the Java and Spring Boot ecosystem, which most people were, there's 2 other interesting talks that you may want to watch as well. So the first one is from Spring.io, and actually you could watch or the 2015 talk from him as well. Both of these go into a lot of detail about the part on why he developed it for hypermedia, and a lot of inner workings about how this whole structure works. And then Anders Evers created a more in-depth example that uses Java and hypermedia, and he'll take you step by step through how to create that first one. Okay. But what I normally bring to the table is a groovier approach, of course, to Spring and Spring Red Sox. Now, Groovy is pretty easy to read too, so the code examples will look the same. The syntax is a bit different than Java, but it should translate pretty well. Okay. So we can take all of these different components. So we can use Spring Boot with Groovy or with Java. In the beginning, we used there were 2 testing frameworks available. So there's Spring MVC and Rest Assured that you can use to hook in with Spring Red Sox. We can take ASCII Doc Documentation, run that through a build system like Gradle. There's Maven too, and then it creates some documentation. So let's start with Groovy and Spring Red Sox. Okay. So I started with a generic project that came out of a Lazybones template. I'm going to add the AsciiDoc or Gradle plugin. In this case, it's mock MVC, and this is Groovy, so of course the tests are going to be in Spock. And then I'll walk through 2 different approaches to publishing your documentation. The first one, of course, is including it as a resource in your project, and the other is to publish it to another site, for example, GitHub pages. Okay. So this is the link to the example. If you get the slides afterwards, those links will be clickable, and it'll take you to the project. There are kind of three main things here. So this is basic URL mappings in a controller. It may not look familiar, but the concepts here are, we have three endpoints. The first one is a list or a search by name. The second one is to get a particular greeting by its ID. And then the last one is going to be to create new greetings. Really simple example for this, of course. So the next step, and the idea here is actually a little bit backwards, right? If you're talking about test-driven development, you'd write your test first. But I'm assuming, of course, that, so most people, particularly for us, we'd already had an example running, and then we were just adding the test and the documentation on top of it. Okay. So there is, of course, a plugin for this that AsciiDoc gets converted into lots of different formats using ASCII Doctor and Gradle. So what does this actually mean? So this is an example of an ASCII Doc file, and it looks pretty similar to markup. It's very text-centric with very minimal information about the formatting in the document itself. We've got config and things that sit elsewhere, but this is really about the text that's in the center. And the nice thing about this is, so you can take an ASCII doc and then you can convert it into lots of different formats. So mostly this is going to be PDF or HTML, but I mean, people have used it to write books. I'm just starting to work on my own, and it works really well for having that multiple exports. In a build tool like Gradle, there's a few things with configuration. So you need to, of course, apply the plugin, and then you can specify all of the different configuration options as far as whether you want your table of contents and all of that, without having to include that in your document like you would with HTML or et cetera. Okay, so if we have our build set up and we actually run it, we can take that ASCII doc that I showed a few slides ago, and you'll get this as HTML output. And of course, you can reskin this and restyle this to your company's example or however you want it, and then actually use those same themes for all of the different output types as well. Okay. The next thing, now that we have an example application, we have some docs, maybe at this point they're just handwritten docs, but we can now add tests. So MockMVC is not the prettiest testing framework, but it is the one that was available from the beginning of Spring Red Sox. Okay. And there are two approaches to this. So one of the kind of really nice things that you can do is that you can test things in isolation. So you can do this standalone setup where you just test a single controller. You don't have to worry about your security setup or any of the marshalling or anything else that happens outside of this controller layer. And you can get started really easily with adding stuff here. But of course, that's not an ideal work or example for most things. By the end, you want the example with security and with all of your filters. So you can do in a full web setup as well. If you are also a Groovy person, remember to use the right version of your libraries, because this is very dependent on Spring. Okay. So now we can actually add the dependency for Spring Red Sox. And so Spring Boot actually comes with Spring Red Sox now, included as a dependency, but you can always specify a different version if you want to by overriding your configuration. It's very similar. There's a similar option for Maven. Okay. Now the important thing with this next part is that we have to tell our documentation where to find the code that we're generating. So we add this, what I'm calling snippets directory, which is then just a file location that I specify in Spring Red Sox. Okay. And we can make this even a little bit more succinct. So if you are in the use case where you're using Spring Red Sox 1.2 and a newer version of Spring Boot. Oh, actually, sorry, that's next. This is the ASCII Doctor module. So ASCII Doctor, there's now a second dependency, which can reduce the configuration. So instead of having all of the different options, if you just want to use the default formatting, you can get it down to, depending on your tests, because you want to make sure that the tests generate your snippets, and then the directory for where you output everything. Okay. Okay, so now we can actually add Spring Red Sox. So you start in your generic specification. So I usually put this is something you do once in your whole project, and then you just reuse the same documentation handler the whole time. It will hook in to the setup for your testing framework, be it mock MVC, rest assured, or something different. And so the way that this works is that it is reading your requests and your responses as the tests are running. So that's where it pulls, so the data that you pass to your test is the data that you're going to get in your documentation. And the response, similar for the response. In this case, we're hooking in the documentation for the get endpoint. The first thing is where this is going to go. And so we're going to create a new folder for all of the examples in each endpoint. You can, of course, specify a whole path here if you want to organize it in a better way. You can both pre-process and post-process your responses. So pretty printing is a pretty good example of a processing of the response that comes back. And then you can verify against the fields. This is, of course, going to get repetitive, so you probably want to define some structures of what your data models will look like, but at least you only do it once in the test rather than having to repeat that everywhere in your source code. For this, we have a simple field ID and a field message. We've got some type information about whether it's numbers or strings. And that information is going to be verified not only at the test level, but also in our documentation. Okay. And then if you were, this is, sorry, the slides that I had inverted. So if you were even in a more special use case, rather than setting up all of the, this part, and setting up kind of where everything is supposed to go, it's now included as part of Spring Boot that you can add an annotation at configure Spring or auto configure Red Sox, and it will do all of this for you. So we're slowly getting towards more minimalistic code. Okay. So now we have some examples. We have some tests that are using Spring Red Sox. When we actually run the tests in Gradle, what happens? So we get some code examples. And so on the left are the ones that we get by default, and the ones on the right are ones we get only when we request them. So you get that curl statement, you get an HTTP request, you get, if you're a fan of HTTP, you get that too. That's a newer, I think that's either 1.1 or 1.2 of Spring Red Sox. And then you can just pull out pieces of it. So if you only want to show what the request body is, but not all the information about status codes and content types and everything, you can just show that part. So what I mean is that this is an example AsciiDoc snippet that was part of the HTTP response. So it's the content type, it's the length, it's an example of the JSON that was output. And this is AsciiDoc that will get converted in the example in a few slides. Similarly, you get response fields. So response fields are just a table, and this is, of course, the structure for a table that you get the path, type, and description. So these two code snippets, when we run them through our ASCII Doctor processor, you get, in this case, a curl statement with all of the text highlighting and everything, your example response, which was the one that I showed, and then that table gets converted. But you may notice that like this works in the simple case, right? As your data structure gets more complicated, you have nested structures. Maybe you don't want that table part, but you do want the example response. You can set this up however you like, and then template all of this, of course. One of the other things that we actually updated in our templates is that we added a fourth column here for optional, whether or not this is actually a required field. You can, and similarly with validation, if there's any kind of validation information. Okay. So the next example is pretty similar. It's just creating instead of listing. Differences here in the content type, and that we're doing request fields instead of response fields. You also notice the addition of optional that turns off the validation. So if this is something that's not in every request, you can specify that, and you can actually read that in when if you create custom templates to see whether or not it's optional. One kind of tricky thing when you start getting into nested and embedded things like lists is that you'll want to remember to use square brackets. It's in the documentation, but just a little bit of a gotcha there. Okay, path parameters are pretty similar. So if you have like /ID in your URL, it can handle that as well. Okay. So now, hopefully at this point, you've got some tests running. What is the expected output? So when things fail, you get pretty decent error handling. So you'll get kind of three main things. The first one is whether or not something was included. So if you change, I think in this case I'd change the name of the field from name to username. And so now it says that I was expecting this thing called name and it's not there. And then there's this thing called username that I don't know what to do with. Then it not only verifies just the field names, but also the type information as well. This is just JSON, so there's not that much type information, but this is particularly helpful in things like XML. Okay. So now we can include this together. So we've got the tests that are generating our snippets. We've got our example doc that is running independently. How do we add this together? So we do that by updating our AsCII Doc file to include. So I talked a little bit about during the configuration of Gradle, how you specify this directory, which we're going to call snippets, to tell it where to look. So in that directory, we tell which ones, like which examples we want to include in our documentation. And then, of course, you can also include references to other pages and split things out in a good separation of concern style. But if you did add that AsCII Doc module, there are some defaults that it'll add for you. All you have to do is, in the bottom in green, specify which example and which code, like a test name, to run, and then it'll include the response field, curl request, and the response. So just shortening it up a little bit more. Okay. So now we've got all of these different pieces running together, and we're going to actually build the documentation. So now where is this going to go? So by default, something like Gradle adds this to your temporary build folder. But you can specify if you want it to go to a different place. So in this example, so source main resources is the Spring Boot place where you can store resources. And you can just add your HTML there. The other strategy is to publish it somewhere remotely. So this is like, that strategy is good if you're just working on a monolith, essentially. You have one project, one thing. But if you want to aggregate this and publish it into a central place and have the documentation for all of your services, you may want to do that instead. Okay. So you can have your wonderful example.com/docs. And so one way to do this is is through plugins. So you can have a plugin like the GitHub Pages plugin for Gradle, which specifies that I want to put it at this example, and then I'm going to pull it from that resources directory. Okay. But you have to also be careful that this can get out of sync again, because you have to make sure that your documentation is getting deployed at the same time as the rest of your application. Okay. So whether you decide to publish it using a plugin or in your project as a whole, you end up with a very nice documentation example. So this is the one that was published to GitHub Pages, and it's also part of the example as well. Okay. So there is another option too. So there is Rest Assured, and Rest Assured is a different testing framework, kind of like mock MVC. And this is how it works for other frameworks like Ratpack and Grails. Because although, and if you do, so if anyone else is familiar with Grails, so Grails is built on top of Spring Boot, and it seems like you'd be able to use some of the Spring stuff, but this is one case where it really doesn't hook in well together. Okay. So one of my contributions to Ratpack was to add Spring Red Sox to the example project. If you want to look at the specifics, the links are there. But the important parts here are that there's a different dependency. So the Rest Assured version and the mock MVC version are kept separate, so you're not downloading a bunch of classes that you don't need, and then things that are in different locations just based on the framework differences. Okay. So in Ratpack, this is what I was talking about with the dynamic handling. So it kind of does some pattern matching for how this works. It's probably a little bit different right now, but there's three basic endpoints here, and the slides go through the same example. Okay. So this is the important part. It looks very similar to the other one, right? You've got mock MVC. Instead of the syntax is a little different. Instead of applying documentation, you're adding a filter. But the really cool thing about this Rest Assured version is that Rest Assured it works just differently than mock MVC. So mock MVC runs against, as it says in the name, a mock of your application. So it's very dependent on things that are running locally, whereas Rest Assured runs against any live URL. So whether that's something locally on your computer, it can be something in a different environment. You can run against any configuration, and that can be very, very powerful, but it also makes it very complex because you have to be a little bit careful about how you expose some of these things. Okay, so that is just the test example. Okay. And one of the things in particular is this host information. So normally with documentation, if you're running against localhost, you want to mask that, and you, instead of saying to run the examples at localhost, you want it against your real documentation. With a solution like Rest Assured, if you change that before the tests actually run, you're going to run against that other URL, not against the one you want. Okay. So this was just another example similar to the first one, just of the response body without all of the content and status information. Okay. Similar things. Okay. So you can also, you'll start noticing as you start creating more and more tests that you want to start using reusable snippets, which will ensure that the data objects are the same across things. This is just reducing a lot of boilerplate, which is one of the things that we don't like about writing documentation in the first place. So this makes it so that I'm writing a bit more code and the documentation's a bit less painful. Okay. So of course, I was talking about with Rest Assured that you can it's very powerful. So I wrote an extensive blog post about how I ran this against a placeholder API. The important part just being that you set a different base URI, and then you can run these same tests against anything. And that may seem kind of strange, like, why am I documenting something else? But maybe it's a different department you don't have control over, or something that you just want to pull a single example from someone else's documentation, or from someone else's API. You can do that too. Okay. So it's been a while. The project that I started Spring Red Sox on made it to production probably about a year ago now, and they're still really happy with it. I keep in contact with some of them. And in particular, the other devs really liked all of our examples, and the CTO was finally happy with the presentation of it. This is only a brief overview of like the really simple case, but you can do really complex things with this as well. The documentation is great. It's a documentation tool. And you'll find lots of information about the complex things with security, how to add information about your constraints, so whether things are nullable or not, if you have ranges, age ranges or such. The hypermedia support is something that I didn't touch on for this example. There's also, this was also all about JSON, so there's XML support too. And you can use, if you really, really want to, you can use Markdown instead of AsciiDoc. There are also starting to be more and more extensions. So if you don't like mock MVC or Rest Assured, there are some other testing frameworks and things like Jersey too that can integrate in with this development cycle and make it better for the pipeline that you have set up. Okay. So in conclusion, API documentation is a very complex topic. There are lots of different concerns depending on where your organization is and where your organization wants to go and what you want to do with those APIs, skill sets, all kinds of different things. There are lots of different tools that you can choose. Spring Red Sox is definitely only one of them that worked for our very specific use case, but we found that it's a very promising tool, particularly because it helped us to enforce good testing and documentation practices without adding anything extra to our source code. And of course, I still write hating boilerplate documentation, but at least it's a little bit less painful when I can code some of it. If you want to learn more, there's a Gitter for Spring Red Sox where you can ask questions. I'm in there. I don't read it so much. I'm more in the Groovy community Slack, but there are lots of places where you can find resources. So just a last link to all of the examples, and of course, time now if anyone has questions. Okay. Otherwise, I know, oh, yes?
You said that with Swagger, the documentation is always really, like you just see the different routes you can specify and no topic-based. And you said with Spring Red Sox you can choose how to group your endpoints.
Yeah.
So I didn't quite understand how that works.
Okay. So the question, to repeat it, is Swagger. I describe Swagger as a URI-centric or this like path-based approach to design, whereas Spring Red Sox has a more topic or resource-driven design practice. How does that work? Because I, of course, skipped that part. So when you create your own ASCII doc, you can put whatever you want in it. And I can, let's see if I can get out of here and go to Chrome and go to one of the examples. Okay, so is this not on the right screen? Okay, so this is the example documentation. Oh, and it goes a little bit off. But the table of contents here is what I described in my ASCII doc, that I want the resources, so the topics are greetings, and then how do you get a list of greetings instead of greeting/list, which is a little bit more tech driven. And So that's mostly just based on how I set up and wrote the documentation. Okay. Yes. I'm sorry? Yes. Oh, right. Yeah. Okay. So the question is, can't you do this with Swagger 2? And the answer is definitely yes. So one of the libraries that I looked at about halfway through is Swagger to markup. So Swagger to markup takes your Swagger specification and generates using the same tooling as this. So it uses AsciiDoc and AsciiDoctor to generate a very similar structured document. So this is just more about the AsciiDoc and AsciiDoctor tooling than about Swagger versus Spring Red Sox, at least in the design part. Okay. If you don't feel comfortable asking in front of the group, you can send me a message on Twitter or email me or find me in any way, and I will be happy to answer more questions. I know it's, yeah, hopefully you can get down a few minutes before the lunch rush starts. So thank you again for having me.